So we're going to do some notes. We're going to take some notes on using function notation. So I think we already understand how to determine if we actually have a function or just a relation. We already know that a function is like a machine. You plug in some numbers, you get out some answers. These are inputs, these are outputs. These are your x values because they go into x. These are your y values because they're answers that are y's. Also known as independent variables, dependent variables. So we already know all that stuff. What I want to start doing is using function notation. Let's actually use this same function, y equals 2x plus 1. So everybody please jot that down again in your notebooks, in your notes, y equals 2x plus 1. And first of all, this is just an equation with two variables. It's not in function notation. If I wanted to rewrite this equation as function notation, I would replace the y with an f of x equals 2x plus 1. So this right here is function notation. Y is the same thing as f of x. F of x is the same thing as y. The only difference is right here, this is in function notation and it saves a lot of time. For example, if I tell you to do this as number 1, f of 5, that actually says a lot. It doesn't mean f times 5. It's read f of 5, and what it's telling you to do is to go to your f of x function and replace the x with a 5. So right here you have an x, you're going to plug in a 5 right there. In other words, you're still going to have the 2, but instead of x, we put parentheses, plus 1, and inside the x, we're going to put what? 5. So f of 5 is function notation. It's really just like notes. It's telling you what to do. It's telling you to plug in 5 into x. And what's our answer going to be over here? 11. Because 2 times 5 is 10. 10 plus 1 is 11. Does that make sense? Yeah. So function notation is kind of like a shortcut. That way, so that's not function notation. This is function notation. So when I say it's like a shortcut, it's because, it's a shortcut. So instead of me telling you guys, hey, I want you to plug in the number -3 for x, instead of me saying that, I want you to plug in the number -3 for x, I'm just going to write this. And just by looking at that, that's function notation. You should know what to do. Okay? So what are we supposed to do? Plug it in. So I'm going to have 2 times x plus 1, and they want us to plug in -3 right in there. So that's going to be -6 plus 1. That's going to be -5 as an answer, as the output. So for my input of -3, I got the output -5. It's just a notation, function notation. And it gets really cool when you have a bunch of different types of functions. Let me show you. So right here we have 3 different functions: f of x, g of x, h of x. So remember, the notation is just so you could know what you want to do. So for example, if I give you h of 0, what am I asking you to do? What does this really say? It's saying plug in 0 into the x value of your h function. So you're not going to plug in 0 up here, that's the f. Not here, that's the g. You're going for the h, and you're plugging in 0 in place of x. That's what this is saying. Go to your h function, plug in 0 in place of x. And there's my work, plugging in 0. 5 times 0 is 0, and 0 minus 1 is -1. So for my input 0, I get an output of -1. I could actually graph that if I wanted to, but we don't have to here. So I could also have something like f of -7. Okay? What does that mean? What am I supposed to do there? Plug it in where? F. Into the f function. So it's going to be 2 times what? -7, and then plus 1. And then 2 times -7 is -14, and -14 plus 1 is -13. So my input of -7 into my f function actually gave me my output of -13. So f of negative 7 equals negative 13. On your answer column, do you have to write f of negative 7 equals negative 13? No. That's just notation. If you want to, that's fine. But all this is saying is when I plug in negative 7 into my f, I get an output of negative 13. But on the answer column on my quiz on Friday, you could just write negative 13 and we're good. Okay? Let's get a little more interesting here. Let's do H. Nah, not H. Let's do G. That one's good. Let's do G of negative 2. So what's this telling me to do? What is this notation telling me to do?
Plug it in G function.
Plug in negative 2 into the G function. How many x's are there in the G function? 2 of them. So I need to plug in the negative 2 right there, and I also need to plug in the negative 2 right there into both of them. Okay? So let me show my work. It's going to be, instead of x, I put parentheses. Instead of x squared, I put parentheses squared. And let me plug in my negative 2 right in there. Negative 2 and negative 2. And now I have to use PEMDAS. So I'm going to start with negative 2 squared. That's going to be a positive 4. I'm going to bring everything else down. So I really have negative 2 minus 4. What's negative 2 minus 4?
2.
Okay, so that is negative 6.
Didn't you say positive 4 in the video?
Let's do one that's even more fun. How about that? F of negative 3 plus 4. What the heck? Well, don't worry about the plus 4 right now. Right now, let's do this. Right? Plug in negative 3 into your f. And then you could do the plus 4. So let's handle this part first, the f of negative 3. And that's really going to be your f function up here, 2x plus 1. Let me rewrite that. 2x plus 1. There's my f of x function. And then at the very end, once I get an answer to this whole thing, then I'm going to add 4 at the very end. Okay? And what is it that I'm plugging in right here? The negative 3. So I'm going to put a negative 3 in there. And I'm going to do this math. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. And then I'm going to do the plus 4 that was at the very end, bring it down, and I'll be able to get my final answer of negative 1. Make sense?
Sure.
You want to do another more fun one?
No.
Yes? Okay, why not? How about that? H of A plus 2. I said, dang. Okay. That wasn't that funny. And we're recording this. Okay. What is this saying, guys?
Plug it in.
To plug what in?
H.
A plus 2. So this is a binomial here. We're actually going to plug this into the h. So here's my h. It says 5 times x minus 1. So we're always going to start by writing it 5 times x minus 1, but we use parentheses. Now, what is it that I'm actually plugging in here? A plus 2. Yeah, exactly. So this is a very interesting one because we're plugging in the a plus 2 right into the parentheses. And we have to distribute. It's an expression that we could simplify by doing distributive property and combining like terms. So when we distribute the 5 times a is 5a. 5 times 2 is positive 10. Bring down the minus 1. Final answer will be 5a plus 9. I mean, if you understand that, dang, you got it all. You understand everything to deal with function notation. Huh? That's it. That's the answer. This input of a plus 2 gave you the output of 5a plus 9. That's like on another level right there. Let me hand out the worksheets so you guys could work on WSP 1.7.